You ever wish like that little scrape on your knee could just like fix itself? Well, what if buildings could do the same thing? That's what we're diving into today, the world of self-healing concrete.
Yeah.
This material is like poised to revolutionize construction.
Yeah.
But before we get too far, let's break it down. What is self-healing concrete?
Right. I mean, so think about the concrete we see all the time, right?
Right.
Sidewalks, buildings.
Yeah.
It's really strong. It's durable. But once it cracks, that's kind of it. Game over. You gotta bring in somebody to fix it.
You gotta jackhammer it out.
Exactly. So self-healing concrete is designed to actually fix those small cracks and damages itself. Automatically. So that means it lasts longer. It's more resilient.
Okay. So it's like concrete with a built-in, like, repair crew.
Yeah, exactly.
But how does it actually work? I mean, is it magic?
Well, it might sound like magic, but it's actually some pretty cool science.
Yeah.
There's a few different approaches, and they all kind of work a little differently.
Okay.
One method uses these tiny little capsules that are filled with this liquid resin, and they're embedded all throughout the concrete, kind of like little microscopic first aid kits.
So what happens when there's a crack?
Yeah. So when the crack appears, those capsules, they actually rupture and they release that healing resin.
Right.
And the resin hardens super fast and it seals the crack right up.
So it's like the concrete has its own internal bleeding control system.
Exactly.
Exactly.
That's wild. But you mentioned there are other approaches.
Yeah. There's another approach that uses, get this, bacteria.
Bacteria in concrete. I'm not sure.
I know, right? Sounds crazy, but it's actually pretty ingenious.
Okay, how does that work?
So they introduce these specific types of bacteria, like bacillus, into the concrete mix. And they just kind of hang out. They're dormant until there's a crack.
Right.
And then water seeps in, and that water activates the bacteria, and they start producing calcium carbonate. And what is calcium carbonate?
That's actually a key ingredient in concrete.
Oh, okay.
So these little bacteria are basically rebuilding the concrete from the inside out.
So like little microscopic construction workers.
Exactly.
That's wild.
Yeah, so they're literally patching it up, and that makes the concrete stronger, even more durable.
So we're like harnessing the power of nature to like make smarter, stronger structures.
Yeah, exactly.
So cool.
There's another approach that uses what we call self-healing materials.
Okay.
And these are things like steel fibers or special polymers, and they're just mixed right into the concrete.
Okay.
And when a crack happens, these materials, they react with water or other triggers, and they form this sealant. It's almost like a chemical reaction that like stitches up the wound.
So it's like we have these tiny little capsules, we have the hardworking bacteria, and we have the reactive materials, all working to keep the concrete strong.
Yeah. A three-pronged attack on those cracks.
Right.
Yeah, and the really cool thing is that all these mechanisms that make the concrete self-heal are always being improved upon.
So it's not just a theoretical concept, like this is actually being used in the real world.
Oh yeah, absolutely. There are some really cool examples out there of self-healing concrete doing its thing.
Really? What, like, give me some highlights.
Yeah, so there's a self-healing highway in the Netherlands. They actually use the bacteria approach to help seal those cracks, and it's really extended the life of the road.
Wait, a self-healing highway?
Yeah.
That sounds like something straight out of a movie.
I know, right? And it's not just highways. They actually used self-healing concrete in the Liguria Bridge in Italy. You know that bridge? It was rebuilt after that collapse, remember?
Right.
And they used self-healing concrete to make sure it stays strong and safe for a really long time.
So this is like major infrastructure we're talking about.
Yeah, exactly. So, and that's just the beginning, I think.
Okay, so we've talked about what it is, we talked about how it works. Now let's talk about why should people care about self-healing concrete? What are the benefits here?
Yeah, so I mean, the most obvious one is that you don't have to do as much maintenance.
Right.
Think about all the time, money, and effort that goes into fixing our roads, our bridges, our buildings.
Yeah.
Self-healing concrete can really cut down on all that.
Less construction, less traffic, less money out of our pockets.
Exactly. Win-win for everybody.
Right. So what else? What other benefits?
Well, since it's designed to last longer, it's way more sustainable.
Okay.
Less environmental impact, less waste. We don't have to use as many resources to keep building new stuff.
So it's good for the planet, good for our wallets.
Exactly. And let's not forget about safety.
Oh, right. Okay.
Because if it's, preventing those small cracks from turning into big problems, it means our buildings, bridges, tunnels, they're just safer.
Okay, so less maintenance, longer lifespan, safer structures, and a smaller environmental footprint. I mean,
Mhm.
that sounds almost too good to be true.
Well, no technology is perfect.
Right.
There are definitely some challenges with self-healing concrete, but the potential is huge. And the research, the development, it's all moving so fast.
I mean, this is fascinating. I'm really eager to hear more about, the challenges and what the future holds for this material.
Yeah, I think we should dive into that next.
So, okay, so we know self-healing concrete has like all these awesome advantages,
Hmm.
but you mentioned there are some like challenges holding it back, right? What are those?
Yeah, one of the biggest things is the cost.
Right. Okay.
Self-healing concrete it's still pretty expensive, especially compared to like regular concrete.
Yeah, that makes sense. I mean, new technology, it's usually pricier at first,
Yeah.
but I imagine like as it gets more popular, the price will come down, right?
Exactly, exactly. That's usually what happens. Demand goes up, they figure out how to make it more efficiently. So yeah, it'll probably become more affordable for like more projects over time.
So it's a waiting game.
Kinda, yeah. What else? Another limitation is, the self-healing. It's really good at those small cracks, but if you get like major damage, like a huge crack or a big chunk breaks off,
Yeah.
then you gotta bring in the traditional repair methods.
So it's not like a magic fix for everything.
No, no, it's more like think of it as like a really good immune system
Okay.
for your concrete. Like it can handle the everyday wear and tear, the little bumps and bruises,
Right.
but if you break your leg, you still need to go to the hospital.
You get a cast. Yeah. Yeah, that makes sense.
Exactly, exactly. Anything else? Oh, and how well it works can depend on the environment too.
Oh,
Like the bacteria, they might not be as happy in like a really dry climate or a really cold one.
so you can't just use it everywhere.
Right, right. You gotta think about where you're building, what the weather's like.
Yeah.
And at the end of the day, this is still a pretty new technology.
Right.
You've got, good results from the lab and from some of these early projects,
Right.
but we need more time to see how it holds up over, decades, even centuries.
Like with any new treatment, right? You
Yeah.
need those long-term studies.
Exactly, exactly. So yeah, the potential's there, but we need more data, more real-world experience.
Okay. So more to come on that front.
Definitely, yeah. But the research it's moving so fast.
Okay.
I think as we learn more, as we refine the technology, it's going to play a bigger and bigger role in how we build stuff.
This is all so cool. It's like we're on the cusp of like a total shift in how we design, how we build the world around us.
I totally agree. And what's interesting is that self-healing concrete, it's not like this brand new idea.
Oh, really?
It has like historical roots,
Yeah.
It wasn't just someone walk up one day and was like, boom, self-healing concrete.
So where did it come from?
Well, the general idea of like materials that can fix themselves, that's been around, but concrete specifically, that's more recent.
Great.
You can trace the early ideas back to the 90s, when people started
Yeah.
talking about smart materials.
Smart materials. Okay.
Yeah, like materials that could like sense changes in their environment and react.
Like they're like alive almost.
Right, exactly. And so how did we go from that to self-healing concrete? Well, there's this Dutch researcher, Henk Jonkers.
Right.
He was like the pioneer. Early 2000s, he started messing around with putting bacteria in concrete, and he figured out how to make them happy, how to get them to produce that calcium carbonate, that healing agent for the cracks.
So he's like the father of self-healing concrete.
He is. He really paved the way. And his work, I mean, it's inspired so many other researchers to jump in to see what else they can do.
Right.
And it's not just bacteria anymore. They're looking at fungi, other microorganisms, anything that might have that self-healing power.
So we're really just starting to scratch the surface here.
Yeah. And that's what makes it so exciting, right?
Right. Right. And as we kind of dig deeper into this world, it makes you think like, what other things could we use this for?
Exactly. And that's what's so cool about it is that there are so many possibilities.
It's amazing to think, right? Like we've been talking about the history, the challenges, but like where else could we use this self-healing concrete if it feels like it could be way more than just roads and bridges, right?
Oh yeah, for sure. We've talked about the highway in the Netherlands, the bridge in Italy, but there's so much more. Think about like old buildings, historical buildings.
Right. Yeah.
We could use it to fix those, those cracks, the damage from just time and weather.
Preserve those old structures.
Exactly. And it's not just about the past, we could use it to build a better future.
Okay, how so?
Think about all the stuff we need for energy, right? Like dams, power plants, wind turbines, all that. Those things are under so much stress, you know? They need constant, like, checking, fixing.
Right, right. Upkeep.
Yeah, but if they could, like, heal themselves, it wouldn't just save money, it would also, like, make them safer.
Right. Less chance of some, like, big disaster.
Exactly, exactly. It's all about, building a stronger energy system, especially as we're trying to move towards cleaner energy.
It's kind of mind-blowing that, concrete, this thing we see everywhere, could have such a, like, a big impact. It really shows how important material science is, you know?
It really does. It's all about, like, finding those new materials, those innovations that can really make a difference.
And speaking of, innovation, we haven't really talked about the money part of it, the economics. We know it's good, but how expensive is this stuff?
Yeah, that's a good point. I mean, we've said it's more expensive than regular concrete, but how much more?
Yeah, like, give us some numbers.
Okay, so regular concrete, you're looking at, like, maybe $100, $150 per cubic meter, something like that.
Okay, that's our baseline. Now, what about self-healing concrete?
Okay, so depending on the type, the method they use, it could be like $200, even up to $500 per cubic meter.
So more than double in some cases.
Yeah, it can be a big jump. That's probably why we don't see it everywhere yet.
Right, it's an investment.
Yeah, exactly. And you got to think long term, right? All the money you save on repairs later, it can really add up.
It offsets that higher initial cost, potentially.
Yeah, and like we said, the price should come down as they figure out better ways to make it.
So it's looking good, even though it's pricey now. But
Yeah.
are there any downsides, like any risks with this stuff we should know about?
Well, always good to think about that, right? um, One thing is the self-healing, it works best on small cracks.
Right, we talked about that. Not a cure-all.
Right. If there's like massive damage, you still need to fix it the old-fashioned way.
Right, the jackhammers come
Well,
out.
exactly. And it's still early days, right? We need more data, more long-term studies to really know how it'll perform over many years.
Makes sense, yeah. But I mean, from what we've seen, it's pretty amazing, right? I mean, self-healing concrete, it could totally change how we build stuff.
Oh, absolutely. And it's just one example,
Right.
of smart materials, materials that can like sense things, react, even heal themselves. That's the future.
Wow, so self-healing concrete is just like the beginning.
Yeah, think of it as the tip of the iceberg. There's so much more out there, so much potential.
I love it. Well, listeners, we started with self-healing concrete, and now we're talking about like the future of materials. It's been quite a journey.
It has. It has. Really shows you what we can do, how creative we can be.
And who knows, maybe one of you listening will be like the next big innovator in material science, right?
Maybe.
It's pretty exciting stuff.
It is.
Well, thanks for joining us on this deep dive.
Yeah, thanks for listening.
Until next time, stay curious.